Huffman coding. These are the letters given and these are the probabilities of these letters. So we'll make Huffman coding or we will make tree. So first with the minimum we will start D and E. So we will make tree for E and D with probability 1 upon 2 to the power 4, 1 upon 2 to the power 4. So what it will be? It will be 1 upon 2 to the power 3. Now 1 upon 2 to the power 3 next. So we will make, we will take on left hand side 1 upon 2 to the power 3. If we combine them, then what we will get? We will get 1 upon 2 to the power 2. Now this is over. Now next 1 upon 2 to the power 2. So again we will add at the left hand side. This is the probability of B. So 1 upon 2 to the power 2. So if we add them, then what we will get? We will get 1 upon 2. This is over. This is left only. So A. What is left? A with probability 1 upon 2. With probability 1 upon 2. 1 upon 2. If we add them, then what we will get? We will get 1. What we will get? 1. So now our tree is completed because all are completed. So we will put bits now. So left hand side 0, right hand side 1, left hand side 0, right hand side 1, left hand side 0, right hand side 1, left hand side 0, right hand side 1. So in this way we put the bits. Now we will see for A how many bits. This is A. For A 0, so number of bits 1. For B 1 0 1 0, number of bits 2. For C 1 1 0 1 1 0, number of bits 3. For D 1 1 1 1 1 1 1 1, number of bits 4. For E 1 1 1 0 1 1 1 0 1 1 1 0, number of bits 4. So we calculate that. So the probability of A is 1 by 2. So average we are calculating 1 by 2 for A, and the number of bits are 1 plus. For B 1 upon 2 to the power 2, number of bits are 2. For C 1 upon 2 to the power 3 and number of bits are 3. For D probability 1 upon 2 to the power 4, number of bits are 4. For E probability is same, sorry, it will be plus 1 upon 2 into 1, 1 upon 2 to the power 2 into 2 plus 1 upon 2 to the power 3 into 3 plus 1 upon 2 to the power 2 into 4 again plus. For E 1 upon 2 to the power 4 into number of bits 4. So if we calculate it, then what we will get? We will get, if we do calculation for it, so what it left here 1 by 2 only, what it left 1 by 2 for this plus again 1 2 cancel, so 1 by 2 plus here 1 upon 2 power cube 8 into 3 plus 16 into 4 plus 16 into 4. Like this we will get, because here, so if we calculate it, so what we will get? We will get 187. So we can say 187 bits per character. So in this way we can calculate, or we can make Huffman coding tree, and how many bits can be represented for a particular word or later we can calculate, and how many bits per character can be possible with Huffman coding, that is possible with this method.